You can see the queue status, the load on the system, some information about the disk usage and disk space, and also the status for all the processors. So for the virtual machine or IntelliVM, 5 processors are online and the sandbox 2 are online. Some information about the license and also some background information about the number of tasks that have been analyzed. Now let's submit a file or a sample. Then you say add files. Okay, let's upload the file. It's uploaded now, and now we can continue. So by saying continue, we can choose the analysis environment for creating tasks.
2 different types of sandbox, one being an emulated sandbox, the other being virtual machine. Our first generations of tools were based entirely on the emulated sandbox, so our IntelliVM is something that's completely new.
So by default, we create a summary capture showing the most important information. If you want to change this, you can also choose detailed capture, then you see every event, or you can even customize specific options, like for example, the memory dump. Also, you can change the timeout. Okay, now we create the tasks. Now you can see everything is processed in different environments in the sandbox, and you can see something that's processed in the IntelliVM.
The Norman sandbox, I kind of like to use the analogy of a video game where you're in a simulated world where nothing real is happening. There's no, actual code running on a real system or anything like that. The video game, you can run around and shoot people and it's not going to escape into the real world. And then with a VM, it's a little bit different. It's more like, a live exercise where you're running around with maybe shooting blanks or rubber bullets.
As a user, you're getting all kinds of overviews about what has happened, when this was analyzed, for how long, and you get some details like what is the file type. You can download the file, and obviously MD5 SHA-256. You get information about the detections that the sandbox has done. So the sandbox has detected this as malware in an obfuscated form and including a backdoor. In addition to that, we have included filters, so you can create your own filters for specific malicious actions. So this file creates a process in a suspicious location, and you can see when you hover with the mouse over it, right, what the actions were. You can see the sandbox detection, and it adds an auto start object, and here you can see the registry keys involved with it. Also, here you can see all kinds of features that we're collecting, like mutexes, processes that get created. You can see the file system events, so everything that was accessed or was created as a file, was written to, deleted. The same for network. You can see which your DNS lookups are performed, where the program connects to. So in this case, you can see it's connecting to the server we gave as a lookup for irc.balls.us on port 667. Okay, some system information, registry information, and API over here. Obviously, when you have a PDF, Acrobat Reader gets started. But we also have another process that gets started, a.exe in Windows System 32, and this is pretty suspicious. So in the network traffic, you can also see some connections to the Taiwanese university. It is just downloading a Taiwanese calculator and executing this. So we get nice screenshots of everything that was downloaded and is then running on the screen. This also allows, for example, to look at fake AV. Also, we are collecting a PCAP of what went on, so later on you can verify and see what actually happened. For example, down here you can see the download of the calculator happening and have the executable in here. So if you know of a suspicious URL, you can point mag2 to that URL. It will analyze it and show you everything that would happen if you had a vulnerable browser on the system. Now let's have a look on the full event list. We are retrieving every event that has happened during the analysis, and that's what makes mag2 special, because the competitors are normally just providing an overview report and not everything that's happening in the system. Okay, so here you can see everything that was going on, event number, by which process and thread ID, what kind of event it was, and also some summary information. So for example, if we're interested in just network events, we can say now, okay, we want IP related events. You can see that the filter is updated here, and now you can see everything that happened. Name resolve, you can see the connect happening, and you can also have a look at all the data that gets sent over the network. If you just search for some data or some event that was occurring somewhere, let's say we're looking for IP send, then we see all the IP send events. Or if you want to look for everything that had the word NIC in there, you can see that here's the network traffic, but we can also see executables that have this term nick in there. So here's the long data, and somewhere in here you will see that there is nick. Here you see it. So all the information is available, so not just that the file is written, but also what was written to the file. So for all the major Windows API functions, we see how often they are called and when, and this can, for example, be very helpful if you see calls like create tool help snapshot 32, or if you see load library, stuff like this. This can really help to detect packers and so on. Based on the filter detection, we also create a rating, and the maximum rating score is used up here, so 10 is very bad. So you can create your own filter by saying write remote process, for example. So something is injecting new code into another process. You give it a risk rating, let's say 6, and option is a filter description. So now we create the filter and can now add conditions. So conditions are a mix of different events that you can see, and you can have a look at all kinds of things that we are collecting. In this case, so we are interested in seeing write process events, and the target process name should contain explorer.exe. So we add this as a filter condition. Now if we look at my filters, we see another filter, write remote process. So if we go back to the SpyEye sample that we had before, you can see that now we have another filter detection, which is write remote process, and you can see this event is also highlighted in red over here. Going back, now we have the data. Now we had the event of a create remote process, create remote thread. So that's related, or you can see this over here. See, the target process is explorer.exe, and this is performed by process 636. So we can also put in 636 here, and we can see actually everything that's going on from this process. And we can see this is a very nice overview, because this process is just doing 11 things, and they are pretty nasty to some extent. One of the most powerful features is you can basically search in all samples for any type of event that may have occurred in there. So in that case, let's say we are interested in all the samples that created this SpyEye mutex. So we say object create mutex, and it contained spynet, and then we want to search for this. And now we're getting all executables that actually were creating a mutex called spynet something, and you can see all these examples in which this occur. Looking at the view event timeline feature. Now here we get the full event view. So basically this is a timeline showing what was going on during the analysis, and you can see the green spots are like all events that happened. You can see sandbox detections, you can see everything related to process creation, file creation, and page faults. So for Timida, we can really easily spot like when the sample was unpacked after how many cycles. So turning off all events and stick with page faults and exceptions. So what you can see is that actually this Timida file is copying itself and then running itself again. And how do we see this? Well, we can see it obviously when we turn on the create process up here, but we can also see it by the page faults happening. So page faults are accesses to memory that are not unpacked yet, and you can see a bunch of those page faults occurring in a block here. Then exception happening here, 2 more page faults, 2 more exceptions. They are basically for debugger evasion, and then a common long unpacking pattern. And you can see that at the very end, this same pattern occurs again over here, the 3 exceptions, and again the rest of the page faults until the sample is unpacked again. So this is the first process up to here. Here the second process gets analyzed, and it's also unpacked. And at the end, you know, you can see very clearly where the sample was unpacked, because no more page faults were happening. So you can see up here no more page faults, and then the sample is basically unpacked.